All right, learners, so what we're looking at here is the proof of the theorem. Opposite angles of a cyclic quadrilateral are supplementary, or they add up to 180, of course. So what we would see in the exam is we would be given this diagram, right? And we would be given the instruction, prove the theorem that states that DCB equals 180 minus DAB. That's in this case with the labels that I've given these vertices. It could be something different. However, what one does is the same. You start by, if it's not already done, you fill in the origin. Okay, called point O. Right, and like we do with many other proofs, we construct two radii, OD and OB. Okay, and we'll write that out as part of the proof. So we'll say construct OD and OB. Now, because they have, because these two lines that we've drawn in consist of O, right, it's pretty clear that they're radii, so they're equal in length. What we then do is we label them. All right, and what this creates is a situation where we essentially have an angle at the center subtended by dB, and we have an angle at the circumference also subtended by dB. Okay, and as we know, in that situation, this angle will be 2 times that angle. We also have the same situation on this side. We have an angle which is subtended at the center and an angle which is subtended at the circumference. But let's go one step at a time here. What we'll do is we'll let this angle equal x, and we'll let that angle equal y. This angle would be DCB, that's what I'm going to call it. DCB equals x. So we'll say let DCB equal x, and we'll say let DAB equal y. All right, so if we look carefully at this, we can see that DB, which is an arc, subtends DCB. It also subtends angle DOB. But unfortunately, in this case, DOB needs to be split into 2 angles, which we will label there, call it O1, and we'll label another one there, call it O2. Now you don't have to draw those arcs in to reference the angles, but it just helps us now to see where they are. Now, what we'll say is we'll say that O1 is equal to 2x. Now, what is our reasoning for that? It is the supporting theorem here, which is angle at the center. Takes a while to write this one out. Angle at the center equals 2 times angle at circumference. There we are. Okay, and we'll say that O2 is equal to 2y for the same reason. All right, so now that we've got that, let's consider that angle O1 and O2 are angles around a point, which is the theorem for a revolution. O1 and O2 therefore add up to 360. Reason being, angles around a point. All right, so from there, let's consider that what we've proven here, O1 equal to 2x and O2 equal to 2y, allows us to write out O1 plus O2 to equal 2x plus 2y, because that is what O1 and O2 consist of, 2x and 2y. Now, if we consider that they're equal to 360, well, we can say that 2x plus 2y equals 360. Now, if that is a bit unclear, just to go into a bit more detail about that, if 360 equals 01 and 02, and 2x plus 2y equals 01 and 02, then 360 and 2x plus 2y are equal to each other. Just be careful when it comes to that step, make sure that that's well understood. At this point, we can do the final part of this proof, which is to remove the common factor 2. 2 times x plus y equals 360, and removing that 2 fully, dividing on both sides, we get x plus y equals 180, which is exactly what we were intending to prove. The proof is done. Right, so to run through the process for this proof once again, we start off given what you see constructed in black, right? We draw in 2 radii, calling them OD and OB in this case. We let DCB equal x and DAB equal y. Those are the angles that we need to prove supplementary. What we then do is we show that O1 and O2, the 2 angles at the center, are they add up to 360, right? What we also do, it really doesn't matter about the order in that step, but we show that O1 equals 2x and that O2 equals 2y. Angle at the center is 2 times that at the circumference is the supporting theorem for that. At that stage, we make 360 equal to 2x plus 2y. We remove the common factor of 2, and we're left with x plus y equals 180. Right, so as a final note for this proof, a good thing to notice here is that we initially made DAB equal to y, and we initially let DCB equal to x. So at this stage, we can actually bring those back, and instead of writing x here, we can write in DCB. And DAB. And if we look at how this has been phrased initially in the instruction, we've been told to show that they're supplementary in showing that DCB is 180 minus DAB. Now this statement, DCB plus DAB, is very similar. It also shows that they're supplementary, but what we would do to finish this one off is just rearrange it so that it matches the initial instruction. And we would do that by just bringing DCB, we bring DAB over the equals, and we say DCB equals 180 minus DAB. At that point, we've proven what we were initially told to prove.